Thanks a lot. Great to be here. As mentioned, I'm from Tel Aviv University, and I'll be discussing a university technology, which is somewhat different than what you would expect at a startup. So first, let's talk about neuropathy. Neuropathy is an extension from diabetes. Diabetes is a scourge of our modern society. It is expanding due to obesity, diet, lack of exercise. These all contribute to the expansion of diabetes as a disease. Even worse, in developing countries, it is expanding geometrically. One of the side effects of diabetes is the loss of sensation in extremities, particularly the feet, which this isn't so bad if you stub your toe, but in actuality, the loss of sensation can cause people to get lacerations and lesions on their feet, which can then develop into gangrene and lead to amputations. Amputations is really not a nice thing to have. It's traumatic and it's also very expensive. Now, with proper monitoring of loss of sensation, the patient can be fitted with special footwear that will protect those areas that are susceptible to damage. How is the monitoring of the loss of sensation performed today? Well, the procedure now is to go to a podiatrist. The patient will then lie down on a bed, and the podiatrist then start to touch his foot with a monofilament fiber, and the patient will then respond and say, "I felt it, I didn't feel it." And by comparing that to previous tests, the podiatrist will know what's going on. We can map his foot. There are a lot of drawbacks to this procedure as it is. It's non-objective. It depends on the angle that the podiatrist comes to the foot with. It is labor-intensive. You need skilled personnel to perform it. And you are testing the patient in his non-natural state, that is, lying down rather than standing. What is needed is an objective type of test that can measure this phenomenon objectively, automatically, and quickly without the need for intervention by a skilled professional. So the idea that we have, and we are planning to build, is an automatic detector where the patient will stand on an array of sensors. The combined sensor and heat element, and randomly he will be exposed to heat underneath areas of his feet. He will then be in front of a touch screen, and he will touch the area of the foot that he felt the heat if he did so. And this way, automatically and without intervention of a podiatrist, you can then map and follow up on what's happening with the neuropathy in these types of patients. There's a clear process of how this is going to work. The device, one stage at a time, and the temperature then can also be monitored, so you can actually have very fine resolution, both of the mapping and of the amount of loss of sensation. Instead of using the monofilament, we're talking about using heat. This has also been clinically shown to be more effective, and there are better resolution of feeling to heat as opposed to fiber, and this has also been used clinically in different applications. The commercial potential here is actually huge. We ran a few numbers on this to see what could the savings potentially be, knowing the cost of amputations and treatment of lesions and lacerations in patients. Just in the modern developed world, we're talking about between tens of billions of dollars and a few $billion. Of course, you'll need a reimbursement on this, and certainly medical insurance companies will easily be able to see the benefits of using this type of device in the clinic. In the competition, well, there are no devices like this on the market. There are heat stimulation devices that are used in neurosurgery and neuro labs. They're bulky, and they have one probe that is activated on a hand or a foot. But this does show that it can easily be adapted to the type of technology we're talking about. We have a PCT, we're at PCT level on this technology right now, and of course as it goes forward we will be patenting it in various countries where there are large markets for this. This is a project under development. We believe there are no real technical risks to this. I mean, it's just a matter of taking known technology and combining them together to make this type of device. And we have a project development line, which includes both building the prototype devices and clinical tests. This is under the auspices of Professor Amit Geffen, who is in our biomedical engineering department and also well connected with local Israeli hospitals and has commitments from them to perform clinical tests as soon as we have it. The budget requirements, well, the reason I had shown you a drawing of this and not the actual devices because we don't have the funding at the university to actually build one. And so looking very short term, we just need about $150,000 to both build and perform the clinical tests over the course of a year. I'm not getting into the business side of this later on. And again, as a university, we're not there. So what we're looking for is either an entrepreneur that can build a startup around this technology and the IP, or a medical company that is in the field and sees this as an opportunity to increase its presence. And I'm from the tech transfer department of the university and looking to make that type of license.